How's it going, everybody? In the following video you're about to see, I'm about to demonstrate two-way duplex communication between two FPGA boards. You'll see that I'll start inputting different combinations on the switches, and you'll see that combination being sent to the other side as LED outputs. Now, 8 bits is not the only size package that you have to send to the other boards. We just chose in this project to use 8 bits, obviously, because there's 8 switches, 8 LEDs. It makes it convenient and easy to visualize the data being transmitted between the two boards. Now, with the VHDL module that we designed, though, however, it's pretty convenient to actually switch up any bit size package that you want to use. So let's say you want to do something with 64 bits. Well, that's not a problem. You just go into the code itself, change up a couple of the vector sizes and some of the variables, and you can easily do that. Along with that, we actually have just utilized 5 pins for this whole design. We have 1 pin using as the master/universal clock between the two boards. We have a TX and RX for serial data, and 2, let's say call it TX and RX triggers to tell the two boards to either start or stop reading data being sent into it. So that being said, if you want to use like an RJ45 port or Cat5 through a Cat5 Ethernet, that's not a problem. You can also have 3 other pins to utilize, so maybe you can use it for some other combinational logic, or actually sending in simultaneously send some different packet sizes. So I don't know, for example, if you want to send 3 8-bit packages at a time, you can definitely do that. Maybe just speed up the rate of the signals being sent to each other. But yeah, you can just see me playing around with the two boards. I'm flicking on the switches, pushing that middle button over there to send it over. With this code, we just wrote it that once you press a button, it writes it into the board as a signal. I believe I forgot what the variable name was called exactly. And then once it's released, it'll start loading that data into the other board and signal that TX trigger to be an active high. And then we use some combinational logic to say that once that signal is active high off that TX trigger, that's when the board will start reading the other data being sent in. So yeah, I'll hopefully get to posting all the VHDL source codes and all that kind of stuff. Also working on a how-to wiki online somewhere, so maybe I'll get that link to all you guys. But thanks for watching.